Area of a sector. Similar to when we looked at area of a length, there is an equation for finding the area of a sector. Now remember, a sector, if we're talking about a full circle, a sector is this part here. So we're talking about finding the area of this sector here. Now your teacher in lesson will probably go through with you how this equation is found. However, on this video I'm just going to demonstrate the use of this equation. Now unfortunately this equation is not given to you in your formula book, so you have to learn it, which is the area is equal to a half the radius squared times the angle theta. So half the radius squared times theta. So let's use this equation on two questions. So firstly, we're told to find the area of a sector of a circle of radius 6.3 centimeters, given that the angle subtended is 0.6 radians at the centre of the circle. So let's just draw a quick sketch of this. So we've got our full circle, and we're talking about this sector here, where we've got the angle is 0.6 radians, and we know that the radius is 6.3 centimeters. So in your formula, AR theta, we're trying to find the area. We know the radius is 6.3 centimeters, and we know that the theta is equal to 0.6. Now it's a simple case of substitution. So area equals a half radius squared theta. So area is equal to a half times 6.3 squared times 0.6, which if you pick up your calculator you get the answer 11.91 centimetre squared. Now that's a very easy question. Let's look at a slightly more difficult question, which could quite easily be an exam style question. It says a plot of land is in the shape of a sector of a circle of radius 48 metres. The length of the fencing that is erected around the edge of the plot to enclose the land is 186 metres. Calculate the area of the plot of land. So let's just draw ourselves a quick sketch. So we've got this plot of land is in the shape of a sector, and we're told that the radius is 48 metres on both sides. Now there's one other key bit of information that we're told in the question, which is the fact that the entire fencing around the thing adds up to 186 metres. So we need to find the area. So we've got to use the two formulas we've been using, which is the length is equal to r theta, which is the arc length, which we've looked at in the previous video, and then we're probably also going to need to use our other rule, which we've just done in this video, which is A is equal to a half r squared theta. Because if we can find out this length here, we can then use this formula to find out what our angle at the centre is, and then we can use our bottom rule to find out what the area of the plot of land is. So the first thing we need to find out is we need to calculate what the arc length is. Now we know that the entire land adds up to 168 metres, so that's 48 metres plus the 48 metres plus the length that we don't know is equal to the 186 metres. And if we just rearrange that and do a bit of subtraction, we get that the length for the arc is 90 metres. So now on our diagram we know that this bit is 90 metres. So we now know what the arc length is, so we can use the top equation to find out what the theta is. So length is equal to the radius times by the angle subtended. Well, we know that the arc length is 90, and we know that the radius is 48 times by the angle, and if we divide 90 by 48 we can find that the angle is 1.875 radians, so rad. Now we can use this information to find out the area. So remember, the equation for finding the area of a circle is area equals a half r squared theta, and we know that the r is 48 and we know that the theta is 1.85. So half times by 48 squared times by 1.875, and if we pick up a calculator and do that on a calculator, we find that the area is equal to 2,160 metre squared. So occasionally in exam questions you may be asked to combine the two rules that you've learned so far to enable us to find the area of a sector given the arc length, just as shown. And remember, you've got to learn both of these rules off by heart for your exam.